Hello class, now I'm going to briefly discuss section 4.3. In section 4.3 we get 3 new properties of logarithms, which you can see written right there. So you may want to pause and write them down or get out your notes from class. And remember, the properties of logarithms follow because logs are exponents, okay? And if you want me to prove why these are true, please ask me in class. It might help you remember them. Okay, so what we're going to do is we're just going to use these properties to either expand a logarithm or condense a logarithm. So I am just going to jump right over and do some that are kind of tricky. We did most of these in class, so I think you guys have enough practice. But let's just start over here at number 5. Okay. So number 5 has log base 5 of, the numerator is x plus 5, the denominator is x squared. So if I'm using my log properties to expand this as much as possible, the first thing I would do is change that division I see into subtraction of 2 logs. And then I check, could I do more? I could. I have an exponent on this x squared here. So what I'm going to do is use the third property I had listed over there, which says if you're taking the log of something with an exponent on it, that changes to multiplication of the exponent times the log. The visual, what it looks like, is it looks like the exponent hops down in front, which is going to turn out to be very useful for us in a moment. So that would be completely expanded. Okay? Let's look at number 6. Okay. The first thing I'm going to do on number 6 is, remember we cannot handle radical notation in logs. We have to change it to exponential notation. So the 5th root is the same as the 1/5 power. And now you have some choices. And I'm going to do this in actually the most difficult way so that you guys can see what happens. I see that this 1/5 power applies to everything I'm taking the log of. Therefore, I'm going to make that hop down in front first. So I'll have 1/5 times the natural log of EY. Now, careful, that's E times Y. Now, if I have multiplication inside a log, that can split into addition of 2 different logs. So I'll have 1/5, the natural log of E. Now be very careful, plus 1/5, the natural log of Y. Since the 1/5 applied to this log, then it has to apply to both of the logs when I expand it. You could put it in parentheses and distribute if you want. Now I'm very happy because right here, what is the natural log of E? We just learned that. It's 1. So the final answer to this is really just 1/5. The natural log of E would be gone, plus 1/5 natural log of Y. Okay? Alrighty. So the rest of these, remember 7 we did together in class? So I'd like you to take a look at that and try number 7 again. And then the next part we do is condensing. And the truth is, condensing is what's going to be very important when we start doing equations. So let's find one. Let's do 14. Let's start right in the good ones there. Okay, number 14. No, that's 13. Here we go. Oops, sorry about that. Number 14. Well, you have some choices. So the first thing I'm going to do is, inside these parentheses, these logs have the same base. Remember, that's the first thing to check. And so I can condense them. The addition, if I'm adding 2 logs of the same base, that means I could condense it into 1 log with the product, okay, with multiplication inside. That's a 7. The log base 6 of x times y. Then I'll have minus 5 log base 6 of x plus 3. I can't do anything with the x plus 3. Okay, now I'm going to make my exponents hop back up. The log base 6 of xy, that's to the 1/7, minus the log base 6 of x plus 3 to the 5th power. And then the last step would be to put them together in a division. log base 6 of xy, let's change that back to radical notation, 7th root over x plus 3 to the 5th root. I'm taking the log base 6 of that whole thing. And that's completely condensed. Okay? Alrighty. I'm going to do number 16 actually. And I'm going to show you a little shortcut. It turns out that if you're condensing logs, first, of course, check, make sure all your logs have the same base. They do. This is base 10. If your log has a positive in front or a positive coefficient, then it's going to be in the top. If it has a negative in front, it's going to go in the bottom. That was a division to begin with. So I count the number of logs I have. I have 1, 2, 3, 4 logs. That means I can condense this down into a single log that has 4 factors. Okay? Now, let's see. Do I have any exponents, any coefficients in front that need to hop back up into the exponents position? No. So I'm going to go straight to a single log. I'm going to make a fraction bar, and I know that the x goes on top times the x squared minus 64. And now on the bottom, because it's minus log of 7, I'm going to have 7 minus this one, x minus 8, is also going to go on the bottom. That's just a shortcut. Okay. All right. The last thing I'm going to talk about is the change of base formula. Okay, so we saw this in class. Change of base. Remember, most calculators can only do logs in base 10, the common log, or logs in base e, the natural log. So if I wanted you to evaluate some other random log, okay, log base b of x, the rule is actually much more general than this, but the way we do it most of the time is we say, well, we can change that to the natural log of x over the natural log of b, the base. You could also do it with common logs. The truth is you could do it with any log of any base, but this is the most useful one for us. So when we do number 17, and it says evaluate log base 5 of 24, that means I'm going to use the formula and find the natural log of 24 divided by the natural log of 5, and that answer from my calculator will be the same as the log base 5 of 24. Okay? And I'll let you do that on your calculator. I'll just write up the other two. The log base 18 of 68.3 will be the natural log of 68.3 over the natural log of 18. Notice the base number goes on the bottom, base, bottom. Okay? And last but certainly not least, number 19. Pi is a number, remember? That's okay. The log base pi of 25, to evaluate that I would find the natural log of 25 over the natural log of pi. And I would get out my calculator and then round it off as instructed. And that's 4.3.